Now let's talk about a type of graph that undergraduates are often tempted to use more than they should, and that is the line graph. So that is a type of graph with an x and y axis, and you draw a line between every single data point. But often, students use this when they shouldn't really. So here is when you should use it. So you've got an independent variable which you plot on the x-axis, and a dependent variable linked to it which goes on the y-axis. And the important point is, and this would be this is always quantitative. Here's a really important point, is that there must be a definite link between the data sets. And most often that's because you're looking at how something changes over time. So most often that means that the independent variable is time. So if you're looking as time goes on, then you know that this thing has to be changing because of time, not in function of time. So you know that they are linked, and this type of graph can be useful. It can be good for looking at the local differences between as you go along the graph. So what do I mean by that? So the fine differences as you go from one data point to the next. So let me show you an example here. So here I've got a data set. We've got an independent and dependent variable. And so my independent variable goes here on the x-axis. So I've got to have my title of the axis and some units, but this is just pretend data, so we don't have any units. And here as well we've got dependent variable with whatever units it would have. Okay, and I'm just drawing this. You'd do it much better because you'd have graph paper and everything. So we've got 12. It goes from 0 to 12 for the dependent variable. That's halfway. You do a much better job. So it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So nicely filling up the space that I've got here. And then I'm going to talk to you a bit more about how to choose what values you have on your axis actually. But here our dependent variable goes from 0.2 and the highest one is 4.1. So let's go up to 5 here. This happens to be 0 for both the axes, but it doesn't have to be. Now I'm going to plot my individual data points. Let's do that in blue. So 0, 0.2. As I say, you would do this much better because you've got nice graph paper. And of course one would really do this on a computer. But I think sometimes it's good to do it by hand, so you think about what you're doing a bit more. So that's why we make you draw graphs by hand. Even now, 0.3, 7, 2. This should really say 2.0, shouldn't it? So it's the same amount of precision as all the others. 8, 4.1 all the way up here. 9, 3.4. 10, 2.3. So that's here. 11. So that's Yeah, good enough. And now I'm going to go ahead and draw a line that goes through every single data point. And of course, if we measured ones in between, hopefully that would give us more accurate information about the details of how this line looks. So there's my line graph, quite messily drawn, just freehand. So we've got labels on here, we've got a line in between, and that's because we know that these are linked, and that's the only reason we're allowed to do that.